Hello and welcome to this talk on bridging the gap between clone and own and software product lines. This is joint work with Timo Kehrer from Humboldt-University of Berlin, Alexander Schultheiß from the same university, and Paul Maximilian Bittner and I are from the University of Ulm. Enjoy the talk. A common situation in software engineering is that Alice and Bob meet in the kitchen. Alice and Bob are Java developers, and why do they meet in the kitchen? Because they need coffee. And as coffee needs some time, they spend some time talking to each other, and today Alice got great news. Hey Bob, did you know you should compare strings using equals? I just fixed my code. And Bob says, incredible, I need that fix. But the way how the story goes in the past was like, yeah, but I also changed a lot of other stuff, so it will be hard for you to find out and take my changes over to your variant. But in the future, the situation is different. Merging is easy because of variant sync. Variant sync is a research project dealing with that problem. We want to show you the problem that we are dealing with, how we want to deal with that, and what automation can help to the developers. So what is the situation that we face here? Alice and Bob are Java developers. They have a large implementation they are working with. Both are working with graphs, with edges and nodes, and in both cases the edges are labeled. However, there are differences because in Alice's part, those edges are weighted and directed, and in Bob's case, those edges are unweighted and undirected. So let's look in the code to understand the problem of merging the fixes. In Alice's case, and we look at the equals method for the edge class, we have to consider the following features. Comparing edges means that edges should have the same weight, same label, same source, and same target. But of course, this very same method must look different in Bob's case. Because in this case, there are no weights, so there's no comparison on the weights, and the comparison of undirected edges is slightly more complicated. So how to get this fix that Alice did in the code? So she introduced the equals method also for the string comparison. How to make this applicable to Bob's variant, and how to automatically find that. So first of all, we consider the domain knowledge. So we know that both have the labeled feature, and this was a change to the labeled code. But we also incorporate that where the code is located for all those features. And by knowing these locations, we can automatically transfer this fix and transfer these edits to Bob's source code. In the following, we will show you where do these feature mappings in the source code come from, how do we derive them, and how this configuration can be used also for other purposes. So first of all, what did Alice do? Alice had an implementation of the code, which was also similar at some point in time to that of Bob. She introduced new code for the new feature weighted, adding this additional expression. She not only added the code, but in our project, in the approach, we assume that she also specifies the feature context. So a formula or a feature that she's currently editing. Of course, there's not only this one change, but there are many changes, and another potential change could be a fix, right? So we have this fix here for the case of labeled edges, where the comparison needs to have this equals method. Even though the code was before unlabeled, an algorithm can automatically determine that this part that has been changed under this context should get another feature mapping. So now we come to the case of Alice and Bob. I mean, of course, in practice, we have many development teams and we have more variants than just two. And in the case of Charlie, it's another story because he even has a new or needs a new variant. So Charlie comes with good news. Can you imagine? We have a new customer. And as Alice and Bob are using the variant sync project, Alice is looking for the sparkling wine and Bob looks for the glasses because they do not need to do anything. They just fix the configuration, they specify these are the features that we need, and this whole variant can be derived automatically. So how does it work? We consider Alice variance as a donor for the feature weighted, we consider Bob's variant as a donor for the feature undirected, and we leave out all the feature traces, all the feature that is mapped to features that we do not need, in this case, the feature for labeled edges. So we derive this automatically, but you can see clearly that this is not a typical merge that is supported in version control. We need to really take care and understand where our features located to make this automatic generation feasible. So overall, variant sync tries to improve the situation of clone and own development. So what does it mean? In clone and own development, developers start by copying an existing variant and editing it to their purposes. Over time, there's an individual development of all of the variants. And with variant sync, we aim to propagate changes between those variants from one variant, one clone to another one as automatically as possible. What are the ingredients that we need to fulfill that vision? First of all the developers need to agree on a consistent terminology of features. Second, for every variant, we need the configuration, so the selection of features that is included in that variant. And finally, for every change, for every edit to one of the variants, we need the feature context in order to automatically derive a feature mapping. Those feature mappings are then not only used for synchronization into other variants, but the mapping is itself synchronized to other variants. This whole approach allows us not only to synchronize between different variants, but also to reconfigure existing variants or even create new variants by considering all the domain knowledge that is out there. With variant sync, we try to overcome a situation that is very cumbersome and requires a lot of effort in state-of-the-art clone and own development in practice. So some of the researchers might ask, so why not using a software product line? So I will give a very brief introduction what a software product line is. In a software product line, we have a mapping from features to code, and all the code that we have is mapped to features, but we have a single code base. And such a code base, in the case of Linux, would use a C preprocessor. So preprocessor directives kind of mark the parts of the code and which parts of the code belong to which feature. So to understand why a software product line is not feasible in all cases and to understand the potential impact of variant sync, let me drive you through a number of diagrams. First of all, what we aim to improve the situation in terms of the mapping of artifacts. Right now we have two dimensions. We have mapping of potential new artifacts or of existing artifacts. And in clone and own development, typically we don't have any mapping at all. This is a different situation in software product line where every new artifact and all the existing artifacts are mapped. With variant sync, we try to support all in between, meaning that we can increase the increase the mapping with newly added artifacts and over time also increase the mapping for existing artifacts. There's another dimension of synchronization. How many of the variants are synchronized and how late does the synchronization happen? With clone and own, typically there's no synchronization going on because it's too much effort to do this manually. In a software product line, everything is synchronized right away. With variant sync, again, we aim to support everything in between. And finally, there's a responsibility either for variants in the clone and own case or for features, and the same also happens for release cycles. They are aligned with each other in the software product line case, and they might even differ in the case of clone and own. With variant sync, we want to support an easy transition from one to the other, where we not necessarily need to reach a software product line in the end. We want to bridge the gap between clone and own and software product lines. We've shown you that we are aiming to reconfigure variants, we want to synchronize changes, we even want to create new variants, and we've shown you that there's a potential impact because there's a large gap in this area where clone and own and product lines really have fundamental differences and we need something in between. Thank you for your attention.
All right, so welcome everybody to the session on variability and product lines. My name is Jo Atlee and I'm the session chair for this session, and I am joined with all four authors of the Bridging the Gap video that you just saw. So Timo, Thomas, Alexander, and Paul are all here. So if you have questions, please put them in the chat for this room, and also please preface them with the question mark button so that we know it's a question and that you're not just chatting with each other. So I really like this work. I think this is the holy grail of product line engineering, right? We do need to be able to bridge the gap between variant development and product line development. So I do have a question. So I guess I don't get my question. So I do have a question from the audience to derive which code belongs to which feature. Your implementations from many configurations, distinguish which feature. I actually pretty much had the same question, right? How do you relate the features to the code fragments, right? Because there's a lot of talk about everything else, but it does seem that you need to have a pretty good, accurate mapping between the code, between features and code. So just the feature identification and feature localization.
So I think one of them, I mean, we're proposing a research project here, and we have started the research project. So I mean, there are many puzzles that need to be done to do that. But in general, what is different to other research is that we want to do this while people develop, right? So while they develop the code, we want to kind of record what feature they are working on, and we want to automate this process as much as possible. So yes, we take into account the configurations, and we also have multiple configurations, and people develop their clones, but we will keep track of the whole history of all the changes that they make, and we will try to include all the knowledge that we have. I mean, the principle is that you specify a feature formula. That's what I'm currently working on, a feature interaction or a new feature. And then you can, ideally synchronize automatically or as much as possible automatically to other variants.
Okay, and so follow-up question is, if you have variants and there's overlap in their feature expressions, how do you, to distinguish two features, you need at least one implementation where features are active and implementations where features are not active. Is that right?
I think it's not right, because I mean, what related work did in most cases or many cases, especially when we go from clone and own to a product line, what people do is they compare different variants, and of course they need to see the feature one selected and one deselected to find out about the feature at all. So in our idea, you could even have all the variants have the feature selected, but the people that are developing, they specify, I'm working on that feature. So that's why it's not needed. You could even start with just one variant, classifying your changes into features, and then later on introduce new variants or reconfigure variants or something like this. But I mean, part of this is in the future, like reconfiguration and so on. It's more our vision. But for now, what we're able to do is we can record the code assigned to a feature.
Awesome. And so slightly different question. So what role and how crucial do you feel clone synchronization and propagating changes across clone and own instances plays in the fuller bridging the gap problem?
Timo, do you want to answer?
Well, I think it plays a huge role, because this is actually the part which causes the pain over the course of time when we're doing clone and own development, right? It's flexible in the very beginning, but it causes the pain with an increasing number of variants and with progress of time, because when there is a problem in one variant, you do not know in which other variants the same problem occurs. And of course, you want to propagate the improvement.
So please continue the conversation in the next.
Hello,